Let's do this. All right. Oh no, seems like there's some kind of problem. But it's actually working. Hard to tell. Looks like it's not working.
Be wrong.
I don't know. It looks like the stream isn't getting enough data or something. Some kind of weird problem with the connection.
I'm gonna take a shower.
Okay, I don't know that you should really be saying things into the stream. I really can't tell if I'm visible or if I'm not visible or what's going on. Okay. Weird. This is not good. Okay, well please stand by as... Alright, let's see if... For me, it's really fighting me. It's showing me that it's not working. Okay. So let's hope that it updates and gives me some. Okay. It just... Yeah, it's really... maybe it's just YouTube. Maybe I'll just watch the stream instead of watching the preview of the stream, because the preview of the stream is messed up. Okay. Let's see, is it actually going to work? Okay. Very strange. I hope that... Okay, cool. Alright, it's like buffering for me and doing all kinds of weird stuff. I'm not connected to any VPNs, am I? No. Alright. Okay. Alright. I guess that's... I guess we're kind of here. I'm gonna go as if we're going. Sorry for all this delay. A very strange amount of buffering and worries me. So, okay. So today we're going to talk about conditional statements. So we're going to talk about if, elif, and else. And basically the only other announcements that I have right now are that I think, so you should be getting Lab 2 this week in your discussion section. It's going to be due next Monday. Homework 1 is out. It's due this Friday. So remember, I've staggered the due dates. So homework 1 is due Friday. Lab 2 is due next Monday, and homework 2 will come out this Friday sometime, right? So, sometime between noon and midnight on Fridays. So, okay. Let's go and do some coding. Okay, so what did we do last week? We remember that there's last week what we covered was we covered print, we covered input, and then we covered the 4 basic data types, which are int, float, bool, and string. So remember, int is just an integer, so its value, well, I shouldn't say its value, its value is basically like -10, -9, all the way up to 0, 1, 2, 3, 4, all the way up to 2,980, 81,000, or 81 million, something like that. Now, this is not the actual max value. Integers in Python are actually implemented differently, so it's possible to store larger values than a standard int. And by standard int, I mean basically anything that, so a 4-byte integer is usually the standard. Floating point, remember this is anything with a decimal. And then we have Boolean, which can either be true or false, and those are really the only 2 Boolean values. And remember that they're both capitalized. And then string is the string, so string of characters. For science or math, well, I would say for okay, it really depends. It really depends. Deletion, on like physical measurements, you're going to use a lot of floats. But if you have something that's an exponent, that'll probably still be an integer. Basically it's just whenever you need a decimal, you use a float. And whenever you don't, use a string. Wow. I hope that all of your streams are way more healthy than mine. My own stream is extremely messed up. So, okay. Actually, what I'll do is I'll start recording. That way, if it's messed up, I can actually repost the video with better resolution. Okay. So, alright, so what are we going to do this week? We're going to do if statements. So remember, we talked a little bit about conditionals last week. So we talked about if. Yeah. Is it okay? Does anything return a string as input as a string? Yeah, so remember that input always returns a string. So if you need, you have to cast to a float or int. It's dangerous to cast to a bool, and I'll show you why maybe later today. But yeah, so it's dangerous to cast to a bool because it doesn't always give what you expect. Okay. So remember how if statements work. If statements, you need to start them with if for if, and then you have some condition, right? So basically, let's say that we have x is equal to 3 and y is equal to 5. So we can have a condition say x is less than 3, or say x is less than 5, and y is less than 10, right? And so what this is, it'll check if x is less than 5, which it is. It'll check if y is less than 10, which it is. And if it is, then it'll print out both things are true. Right? So let's run this. There we go. Both things are true. And so what other kinds of things can you do with if statements? So you can use strings in if statements. So if you have like s is equal to input, enter a string, and then we say if s is equal to stream, and y is equal to, let's say y is equal to int input, enter an integer. And so if y is equal to 5, then we print out, right, whatever. 5 times 5 is 20. I don't know why we print that. That's stupid, but who cares? Let's see. Do you have to put the semicolon? No. So, oh wait, I'm sorry. So it's not a semicolon. So remember, at the end of every if statement, you use a colon. And then basically anything inside of the if statement gets tabbed in by one level. So basically, this is inside of the if statement, right? And this is not in the if statement. And so basically, if we run this thing and we enter a string and we say ASDF, well, let's do stream and 5, then we say this is inside of the if statement, right? And then this is not inside of the if statement. But if we enter something like ASDF and 2, then we're going to get, we don't see this statement, we don't see this print, all we see is this. And so basically what happened is that this if statement executed, and then it said this if statement is false, so then it jumps over all the code that's tabbed in, and it goes right to here. So, yeah, in other languages you might use a semicolon, but in Python, semicolons are not actually, I don't think they're actually necessary for anything. No. So just because you have an if statement, you don't need an, and of course I haven't even said what an else is, but you can kind of guess. So let's say that we have input, enter another string, right? And so let's say that if another string equals go, and of course here I did the wrong equals, there we go. Remember that there's 2 equals in programming. There's assignment and there's conditional equality. And so conditional equality, the double equals returns a true or false value, whereas assignment actually just assigns. And so, oh, do you have to leave a blank line at the end of an if statement? I like doing that just because Python is a white space sensitive language where tabs matter and everything matters, and I think it's a nice good divider. Yeah. So we're gonna print let's go. And so what if we want to print something if this statement was false? So you can do something like this. So basically here, let's run this program. So ASDF 3, enter another string. So let's type go, and then it says let's go, right? Now here we're gonna have ASDF 2, and so here, what if we say stay, right? And so it's gonna say let's not go, like this. But you see that this is a little bit, so actually this is a little bit dangerous. So let me explain why this is a little bit dangerous. This is a little bit dangerous because what if you say this? Right, so what if you make a modification? If you make a modification to the first if statement, then it's not exactly the opposite of the second one anymore. So the problem with that is that what's going to happen is if we type in, watch this. So if we type in capital Go, print out let's go and let's not go. Because remember, in programming, at least these if statements here, they are case sensitive, right? So what does that mean? So case sensitive means that like go is not equal to go in lowercase. And so these two things are actually separate conditions in the if statement. They actually evaluate differently and all of that. And so here, this is not a good way to do it. You don't want to ever have an if statement and then right after an if statement that does negation. Because if you do that, then you can accidentally change the first if statement if something changes in your program, but then you forget to change this one, right? If you forget to do this, then you're in trouble. So is there a way to... So of course, is there a way to always execute the second condition whenever the first is false, right? And the answer is yes, right? So basically we can have if x is bigger than 3, we print x is big enough, and then we just write else. And so the keyword else is a keyword in Python, and you just type else with a colon at the end. And so when you type else with a colon, you can say x is too small, right? And so here we're going to do x is equal to int of input enter x, right? So let's do that. So okay, so now we want to enter x. Let's say that we enter x is 5. X is big enough, right? Actually, let me okay, that should prevent all that from running. Can I have 2 if statements? No, you can definitely have 2 if statements after another, right? This is an example of 2 if statements, one following the other. All I'm saying is that if you have 2 if statements where one is like, here is another string equals go, and this is another string is not equal to go, right? And so the point is that maybe you think, oh wait, I want capital letters too, so you put this into the first if statement, and you think that this is still doing the opposite thing of whatever this one is, but it's not anymore. So that's why we would use an else statement. So for instance, like, so here, let me just show you an example. So here, if we say 5, x is big enough, and then we set 1, here it's too small. So the good news is if I decide, right, so let's say I decide to change this from x bigger than 3 to say x bigger than 5, now I don't have to change the second condition. All I have to do is do this, and now here if I put in x is equal to enough, if I put in x is equal to 4, x is too small, so I don't have to change 2 if conditions, right? This one executes, so the first one, if statement, executes when the first condition is true, and the else evaluates whenever the first condition is false. And so the good news about that is that if you have an else, else is guaranteed to execute if the if statement doesn't execute, right? So it's basically like you can either go down the if path or the else path, but you have to go down one of the paths. You can't just skip it, right? Because in a standard if statement, if you have like if x is equal to 2 here, print x is 2, And if you have if x is equal to 3 here, print x is 3, then it's possible that this if statement will execute. It's possible that this if statement will execute. It's possible that both of them will execute. Well, in this case, it's not really possible, but it's theoretically possible that both of them could execute, or neither, right? So those are the 4 possibilities, and you would have to kind of worry about that. So, for instance, here you can say, you know, x is too small and x is equal to 2, and here if we put in 3, it would say x is 3. But then if we put in, say, x is equal to 4, neither one of these execute. And then we could also have something where it says, like, if x is less than or equal to 3, print x is equal to 3. And so if we put in, say, 2 here, then you see that both of these if statements could execute. So if you ever want to avoid that happening, right, if you ever want exactly one thing to happen, then an else statement is the right way to go. So for instance, if you have like a menu, right, so let's say that we have print and to start game, 2 to load, 3 to save, 4 to quit, right? And, oh, I guess we should input. So if you're doing a game and you have a menu selection, right, and you do something like this, then you might say, like, if menu select is equal to 1, then print time to play a game, right? And then you might say, if menu select is equal to 2, you might say print time to load a game. And then if menu select is equal to 3, print save game time. And then finally, if menu select is equal to 4, you might print quitting game, right? So this is one thing that you could do to basically have a whole bunch of options, right? But the problem with this, okay, so the issue here, so what can happen if you do this kind of thing? So for instance, okay, let's tab all this in so that it goes away. Pretend it's not here, right? This is the only code we have. So if you say 1 to start a game, it'll say time to play a game. 2 to load, time to load a game. 3, time to save a game. And 4, time to quit. But okay, so this is okay. But what if we enter something off the list, right? If we just do an else here, that's not on the list, right? So if we do an else here, what's going to happen? So this is actually a good question. This is like an exam type question. The reason why, so the reason why else is not great here is, watch this. So if I hit 1, it says time to play a game, and then it says that's not on the list. So why did it say that, right? Because this if statement here is actually completely disconnected from this next if statement here, is completely disconnected from this if statement here, and is disconnected from this if statement here. But this if statement is connected to this else, right? So this if statement is the only one connected to the else statement. Okay? So basically that's the problem with this. So how do we fix this problem? So what do we do? So there has to be a way around this, right? There has to be a way to fix this, right? Because otherwise coding would be horrible. And the answer is, don't worry, there is. The answer is Elif. Elif is short for else if, which, let's rewrite this piece of code. And let me just show you how to use elifs instead. So here, if this one turns out to be false, what we're going to do is we're going to use an Elif here, and an Elif here, and an Elif here. And so now, when you have Elifs, they connect with the first if statement above. So here's the main if statement. If this one turns out to be false, it goes to the first Elif. If this turns out to be false, it goes to the next Elif. And so on and so forth, all the way down, right? And then there's no next Elif here. And then here it just goes to the else. Okay? But here's the good news about Elif statements. Only one can ever execute. Okay? So what that means is that if you have something here where you say menu select is equal to 1, it's never even going to test the rest of this stuff. If you say menu select is equal to 2, it's going to get to here, it's going to print this, and then it's never going to ask these other questions. Same thing when you go down to menu select 3. So let's actually run this thing, and let me just do this so that... Okay, let's do this to show the power of Elif. So here, menu select, say, is equal to 1. So time to play a game. 2 to load, right? 3, save game. 4 to quit. And let's say we put in 5. That's not on the list, right? So what happened in each case, right? When we entered, actually, let's even just do it. Let's enter 3. I think, let's enter 3 and see what happens. Oops, that's not exactly what I wanted. Why didn't it break? Oh, because I didn't run the debugger. Okay, there we go. So let's enter 3 and watch what happens. So here it says menu select. I don't know if you can read this, but it says menu select is equal to 3. So what we're going to do is we're going to say, is menu select equal to 1? No. Is menu select equal to 2? No. Is menu select equal to 3? Yes. So then it prints save game time, and then it jumps out of here. So it only executes one of these Elif blocks. So for instance, it's always possible that you can have overlapping conditions, and let me show you what I mean by that. So if I have x is equal to int input, enter an x variable, and you say if x is, let's say less than, or no, yeah, let's say is equal to 0, print x is 0. Elif x is less than or equal to 0, we can print x is negative. And of course this is actually not a very good way of doing this, but and you might be tempted to say, hey, wait, x has to be less than 0 to be negative, right? When x is equal to 0, it's neither negative nor positive. So is this going to produce the correct answer in all the cases? Well, let's see. So, okay, let's put 4 to quit. Then we have to enter an x variable. Of course, quitting does nothing. That was just a sample menu for a game or something. So let's say we put in 0. So here it says, if x is equal to 0, then it prints this thing. You notice that x0 is less than or equal to 0. So this is actually still true, but it never gets here, right? Because it executed the first if condition. Whenever it finds something that's true, it executes that condition and then jumps out of that block. So this whole thing is basically a conditional block. So the, well, let's see. Arguably, oh man, yeah. That's the trick question, right? So, and maybe I'll talk about mod in just a second and make everybody very unhappy. But why didn't it print out x is negative, right? Because x is less than or equal to 0, and this should have printed out, right? Except for the fact that it only executes one. So it only executes one of these, so it catches it on the x equals 0 condition before x less than or equal to 0. Now, of course, if you were really doing this as a good program, we'll sign in, right? So, get rid of that equal sign to make yourself not introduce bugs later, right? Because if you ever move these if conditionals around, like for instance, here's the good example. If we say, I have an idea, I'm going to do it this way now. So now we're going to do it this way. Yeah, absolutely. The less than or equal is unnecessary, but I introduced it just to prove that even though it's also true, it doesn't get executed because the if statement already did. So what if we do it this way, right? And this happens when you say, I need to flip these conditions around for whatever reason, so I've flipped the condition around. Right, so here, there we go. So if we flip these conditions around, then, and I don't know why I still have that in there. Okay, so enter an x variable. So what if we put in 0 now? So for the first one, it's going to do the same thing. It's going to print out x is equal to 0. But here, since x is less than or equal to 0 happens first, yeah, these would both need to be ifs if you want both of them to execute. And so here it says second x is negative, right? So when it gets to this line of code here, it catches on this equal sign, and then it doesn't execute the code that you actually want to execute. So that brings up a good point, which is be careful. Crap, come on. Okay, there we go. Good. So your if, elif, else order matters. Now this is a dumb example, because you probably wouldn't include that equal sign, right? That's really. But the reason why I'm doing that is because a lot of times what you're going to see is, let's do a more kind of reasonable example. It's like the difference between, say, if we print it, say we input, how much money do you have, right? And so, money. And so if money is, say, bigger than 10 to the 9th, which is 1 billion, $1 billion, then we print out, you are a billionaire, right? And then if elif, money is bigger than 10 to the 6th, which is 1 million, we print out, you are a millionaire. And then elif, money is bigger than 10 to the 3rd, we print out, I guess, you are a 1,000 air. And then else, we print out, sorry. So, okay, so let's run this program. Let me just, you might notice that I'm tabbing all this stuff in. This is just I'm using a stupid trick to make sure it doesn't run. I just want to run one thing at a time. When I actually upload this to the GitHub, I'll probably untab everything. So how much money do we have? So let's say that we have 123, or no, let's say we have, is that $1.2 billion? So here it says, you are a billionaire, and then if we put in, $1 million, it should be, so notice that it should be, bigger than or equal to. Yeah, so here you're a millionaire, and having $2,000, you're a thousandaire, and $6, $5, sorry. So, okay, so we look at all this and we say, okay, cool, that's fine. But what happens if we put this in, say, the reverse order, right? So what if we said, let's say if money is bigger than this, and then we kind of reorganize it like this. So here's the same code basically, except it's reorganized in a reverse order. So now it's going to say if money is bigger than 1,000, you're a thousandaire. So I'm going to say I have $10 million. So the first piece of code tells me I'm a millionaire, which I think is right. And the second one just says, oh, you're a thousandaire, the name I made up for, having $1,000 or more. And you're like, wait a second, right? But you're actually in this block. But remember what happens, right? What happens is that it checks this condition, and it says, yep, you have, does a billionaire have $1,000? Yes. Does a billionaire have $1 million? Yes. So a billionaire would get caught on either this condition or this condition before they get to here. So this is in the backwards order because, it catches on lower amounts before higher amounts. And so in the case that normally you would say, I guess Jeff Bezos or Elon Musk or Bill Gates or whatever, they're billionaires. I mean, technically you would say, if you ask the question, do they have $1,000? The answer is yes, but that's not relevant, right? You wouldn't say that that's an important fact compared to the overall amount of wealth. And so it caught on this if statement before it executed these two, right? So this is a backwards order. It's not what you mean. So that's why you have to be a little bit careful. And then here's the last thing, let's do this again. Only this time what we're going to do is take off the elifs and see what happens. So now let's say that we have let's say we have $1 billion, right? So if we notice what happens here, okay, well we definitely need, third test. We need to separate these things, otherwise it's just going to be very confusing. Okay, let's do it again. So for the third test, without the elifs and without the else conditions, you see that what's happening here is that you have $1,000, you have $1 million, and you have $1 billion. So it's telling you all three things. The second test is showing you that if you do it in the backwards order, meaning this condition is more specific than this condition, but whenever this condition is true, this condition is true, right? So, and whenever this condition is true, this condition is true. So basically, because of that, this is the reverse order. You need the most specific condition first, and then you have to get less specific as you go until you get down to your else. So, and then, so basically here, so here it's going to print out all three because there's no elifs to prevent it. So here, these are three disconnected, basically logically independent tests. They have nothing to do with each other. They're just going to run independently and print out if they print out and not if they don't. So there are times where you want one of these things. There are times where you want the other thing. You generally never want this, because this is telling you a more specific condition before a more general condition. But there are times where you want this type of logic, and there are times where you want this type of logic, where you would want something to be true for all three, and to execute every time. So so let's discuss. Let's discuss mod. So So remember last time we talked about the double divide, which is integer division. So remember what I showed you last time. If you do like 5 divided by 3, if you do say 17 divided by 21, that should turn out to be 0, 17 divided by 5, etc. So if we look at these numbers, and let me just tab all this in to make sure nothing happens. Okay. There we go. So if we look at all these numbers, so 5 divided by 3 with the double divide is just 1. 17 divided by 21, right, is 0 because, well, 17 is less than 21, so how many times does 21 go into 17? The answer is 0 with a remainder of 17, so it doesn't go in. And how many times does 5 go into 17? The answer is 3 times, right? Now, as it turns out, when a computer does an integer division, it actually computes 2 things at once. The first thing it computes is the answer to the division. But the second thing is the remainder, okay? And so remember, back from, you know, I guess, so go all the way back and think back to elementary school division. So this is not long division, this is elementary school division, right? So when I used to ask, you know, a student or a human being, what is 6 divided by, well, 6 divided by 3 is 2, so that's stupid. Let's do 7 divided by 3, right? And so that person would say, it is 2 with a remainder of 1, right? Because 2 times 3 plus 1 is equal to 7, right? So that's, so for instance, 19 divided by 5 is equal to 3 remainder 4, and the reason why is because, 3 times 5 plus 4 is equal to 19, right? Because this is, basically you get quotient, remainder, well, I guess quotient, where Q is quotient, and R remainder. So you want to be a little bit careful with negative numbers. So like minus 2 divided by 5, remember how that was equal to minus 1. So if that was equal to minus 1, what is the remainder there? So negative 1 times 5 plus x is equal to minus 2, right? That's the equation we have to solve here. So here this is negative 5, so we can add that to both sides, and we get x is equal to 3. So x is equal to the remainder. So basically we're going to get negative 1 remainder 3. And so let's try this out. So in Python and in C++, Java, JavaScript, you know, C#, Ruby, I think, Python, whatever. So basically, most languages, the remainder or mod operation is %. Okay, so there are some I'm sure there are some languages where mod is not %, like maybe Lisp or Clojure or something like that, probably. But mod is almost always %. So for instance, let's print out some mods. Let's say 7 mod 3. Let's print out 19 mod 5, negative 2 mod 5. What else? 123 mod 4, I guess. That should give us 3. Stuff like that. So remember last time, so about your question, remember how last time when we printed out negative 2 divided by 5, that came out as negative 1 here. And so your question is, why does Python do this? And the answer is, it's very likely that the stream has some issues. I definitely apologize. So I might, if the stream is blurry or if there's actual real issues with it, then I might upload the video. I'm actually recording the video right now. I'm experiencing extreme problems on my end. So why does Python do this? The answer is because, for instance, 0 divided by 5, 1 divided by 5, 2 divided by 5, 3 divided by 5, and 4 divided by 5 are all equal to 0, right? And so here, we want only 5 numbers to get the same result when you divide by 5. So we could do it as you do it in you could do it when like if you just think that it's rounding down, so -1 divided by 5, could be 0. But the answer is actually -1. So for instance here, -1 divided by 5, -2 divided by 5, -3 divided by 5, and -4 divided by 5, and -5 divided by 5 are all equal to -1. And the reason is because division in this case gives us exactly 5 numbers, right? These numbers are all equal to 0, these numbers are all equal to -1, etc. And so it also guarantees that the mod equation always works, because whatever you do, if you say print, or let's say x equals int input enter numerator, and you say d is int input enter denominator, and then here we can do our first safety check. If d is not equal to 0, then we print out x divided by d, x mod d, and then we can even print out d times x divided by d plus x mod d. And I think that should get us back to x else. Yeah, -2 divided by 8 is -1. Yeah, it's... No, so it's always... Yeah. So for instance here, enter numerator, or like, what do they call it? The dividend, I guess, and the divisor. Let's say that we enter 155, and we divide it by, say, 17, right? And so, basically, 155 divided by 17 is 9, which means it goes in 9 times. The remainder is 2, right? So this is printing out the number of times d goes into x, then it's the remainder afterwards, and finally it puts it back together. And so the other reason that this happens is, if you remember all the way back to elementary school math, remember a fact about the remainders. Remainders were always strictly bigger than 0, or strictly bigger than or equal to 0, so they were strictly non-negative. And so you never had a remainder, you never did a division where you said, like, -1 divided by 5 is equal to 0, remainder -1. So that's actually the secret reason. Like, here, these are the 2 options that we have. Sorry. -1 remainder 4, yes. The quotient, remainder must be positive. Okay, so Python here is enforcing elementary school math. Okay? Now, I want to say that my last thing is that I'm not going to harp too hard or test too hard on the negative stuff. I just want you to be aware of it. The real issue here is that other languages don't do this, so they'll allow negative remainders and stuff. This is specifically a Python thing, right? Python does this particular thing. Now, all languages have mod, but a lot of languages will not. Yeah. It's telling you how far you are away from being evenly divisible, right? It's telling you, and it's always telling you a positive thing. It's not telling you the negative version. Because, I mean, even if you did say 4 divided by 5, right? 4 divided by 5, you could either say that's equal to 1 remainder negative 1, or you could say it's equal to 0 remainder 4. And so we pick this one. Okay. So, all right. So a common problem that we tend to give in this class, let me see if I can draw it. I'm a little curious if I can do this. I'm sure it is. There's very little I can do about it. I'm experiencing, as I said 100 times, I'm experiencing extreme problems. Yeah, I mean, if you refresh it, sometimes it improves it. So I'm thinking I could do something like this, but maybe that would be stupid. I don't know. Let's just draw a circle. Oh, I can draw a circle like this. I wonder if I can make a custom angle. Okay. I know there's a rotation. Let's just try to draw a regular circle and like just kind of do it in a silly way. Okay, there we go. So let's say I do this. Let's say I'm trying to make these even. Let's see, 4, 5, 6, 7. Sure. Okay, so I mean, YouTube is definitely having issues, or something's having an issue that is not good. So, pretend these are equal. Right? And let's say you have a spinner. Right? And so each one of these, let's say there's 10 regions. So each is 36 degrees, right? And now the spinner can spin around multiple times, but wherever it lands, what we need to know is, which region is it in? So let's say that, so let's say that we want to calculate which region it's in. And so here, let's say that this is region A, region B, C, D, E, F, G, H, I. So here's all of our regions. Pretend they're equal. I'm sure there's a better way to do this with Inkscape. I mean, 100% there is, but I just wanted this quick. So each is 36 degrees. So basically, if you enter, right, if you enter a region, so if you think about this problem, a region between 0 and 35, we want to get A, 36 and 72, or I guess 71, we want to get B, etc. So, yeah, I know you counted. As I said, pretend. Pretend, pretend, pretend. No one's pretending. Are there 9 regions? 1, 2. 1, 2, 3. Yeah, I guess there's 9. Okay, 9 regions, fine. So now we have to, unfortunately now I have to think about what 360 divided by 9 is. 40. Okay, each one is 40 degrees. So yeah, 40 degrees. All right. Oh yeah, 10 lines would break. Does that work? Huh. Anyway, so okay, so we want to figure out which region we're in, and so how do we do that? So basically, my hint is int divide by 40, which is the number of degrees per region, right? And get the region, right? So basically, what we're going to do is we're going to make a horrible long list of if statements. So let's say we get degree equals int input enter spin degree. And then what we're going to do is we're going to say if degree divided by 40 is equal to 0, print A. And I mean, I know this is probably, well, no, I shouldn't say I know this is probably. This is almost certainly, definitely the wrong way to do this, but this is kind of a hint for homework, and this is how you're going to do it initially, right? So just while you know if statements. So B, C, D, E, F, G, H, I. Okay, so let's make the 2, 3, 4, 5, 6, 7, 8, 9, something like this. And so this will be I, H. I'm gonna have to go from C, D, E, F, G, H, I, and then I'll put an else here. Print. Okay. So basically, you see what I'm doing here. If the degree divided by 40 is equal to 0, so we're in the range of 0 to 40, it'll print A. Degree is 40 to 79, it'll print B, etc. So let's run this program a few times and just watch what happens. Oh no, this is definitely something, this is like a homework problem that we always give. So let's enter the spin degree. Let's say it's 120. So hopefully that gives us what? D, right? Yep. So 120 degrees is going to give us D because degree divided by 40 is equal to 3. So we notice that 121 is going to give us D, 159 is going to give us D, and then 160 should give us E, right? So 160 gives us E because it pushes us into the next region. 170 is going to give us E. Well, 174 is going to give us E. 180 is going to give us E. 200 is going to give us F, right? So 0 is going to give us A, etc. So here's the thing. Is this complete? No, because remember the spinner can spin around multiple times. So if I enter, for instance, 720 degrees, it's not going to know what to do. Okay? But here's the trick. What do we know about angles? Right? So what do we know? Angles. Versus, say, maybe what they call reference angles or is that what they're called? Well, okay. So what do we know about angles? Basically what we know is they repeat geometrically every 360 degrees, right? So what we could do, if we were creative, to solve this problem, is we could take the degree and we could say degree mod equals degree. So let me show you what happens. Terminal angles, I think that's right. It's not reference angles because reference angle is the minimal angle between that and the x-axis, which can... So let's say that we enter in negative 50 degrees. So what should that do? So negative 50 degrees should give us... interesting. I don't think that's right. Oh! Okay. No. So this is... Let me just show you what I was doing. Okay. I'll do it this way first, and then I'll use the mod equals. So that was a bug. So, okay. Why did this turn out to be h? So let's think about it this way. Let's look at our circle, right? So our circle, this is 0. Of course, not a very straight 0, but it's a 0. This is 40 degrees, so this is minus 40 degrees, and so minus 50 degrees will push us into this h region a little bit. And as it turns out, that's exactly what happens, right? Minus 50 degrees, when you mod it by 360, will turn out to be 310. Yep, it went the other way, that's right. So let's say that we do 720 degrees, right? So 720 degrees is 2 full rotations, so that should end us up back at 0, and it does, look at that. So 720 mod 360 is 0, because the remainder is 0, and so it puts us right into the A region. Let's say that we do 3 rotations, so 360 times 3, that's 1080, plus say, I don't know, 73 degrees. So that would make it 1153. So this is 3 rotations plus 73 degrees. So 3 rotations plus 73 degrees should put us in the B region. And it does, right? Because when you divide 73 by 40, you see that we haven't quite got up to the 80 degree mark, so we're not in C region yet, we're still in the B region. And so this basically allows us to cycle around, okay? So interesting. It's interesting because the comment stream on my broken YouTube feed is much faster than the comment stream actual streaming site through YouTube. So it's things are very strange. Okay. So here's another interesting thing to do with mod. Oops. And so you're going to find out that parity, which is the evenness and oddness, right, of a number, comes up a lot in computer science. And so a lot of times you want to check to see if something is even or odd. So how can we use mod to check if a number is even or odd, right? And so think about the definition. What is the definition of an even odd number? And what is the definition of an odd number? And then my trick question is 0, even, or odd, both, or neither. Right, so you're saying we take mod 2. And so what's the definition of an even number? Remember, the definition of an even number is an even number is an integer for which there's another integer, k, so that n is equal to 2k. This is the number theory way of saying it. The simple way of saying, the more simple way of thinking about it is, it is divisible by 2. Now, when we say divisible, we mean evenly divisible, meaning no remainder. So, if it doesn't have a remainder, right? If it doesn't have a remainder, yeah, 2n or 2n plus 1. That's like the number theory definition. So basically here, it's divisible by 2, meaning it's evenly divisible by 2 with no remainder. So if our number mod is equal to 0, then our number was even, right? And the same thing here. Basically, if n is equal to 2k plus 1 for some integer k, then n is odd. And the way to think about it this way is if our number, mod 2, is equal to 1. Now, in some other programming languages, you might have to check if it's equal to -1 or 1. But in Python, we can just check if our number, mod 2, is equal to 1. So, basically, this allows us to check for the evenness and oddness of a number. And you might think, yeah, you could say our number mod 2 is not equal to 0. Yes, that's true, that's true. I'm just saying that in other languages, you cannot just check for it being equal to 0 and 1. You might have to check for, as you say, 0 and not 0. Exactly. So now here's the question. Is 0 an even number? And this is nothing related to programming. This is just my own little trick question that I ask every semester. Is 0 an even number? An odd number? Is it both? Or is it neither? And I'll take a sip. While you think about it. So, yeah. So the good news is that 0 is even. The reason why it's a trick is because everybody thinks in your brain 0 is... Everybody thinks 0 is neither positive nor is it negative. And so basically what your brain does is it says 0 is neither even nor odd. But that's not right. So the good news is that Python understands that 0 is even, right? Because 0 mod 2 is equal to 0, so it's even. In the number theory definition, k is equal to 0, so 2 times 0 is equal to 0, so even again. So there's good news here, right? Negative 0. Negative 0 exists in some computers, hardware, but thankfully not in the past 30 years or so. Basically, negative 0 existed because they used to store a negative flag, and so you could have either a positive 0 or a negative 0. And then computers would have to do a lot of extra work checking to see if... so basically the 8086 and the 8064 architectures, ARM, don't have negative 0. And I promise you that unless I can't imagine what computer you're using right now, but if you're using a laptop, you're probably using something in the 8064 architecture. If you have an Intel or an AMD chip, if you have an Apple, a PC, a Linux, whatever, and if you're using a cell phone, then you're using some kind of ARM core, and they do not have negative zeros. So it used to exist, but it doesn't anymore. Okay, so, all right. And I'm just writing this little bit of code here. Okay. So there's no negative or positive zero in mathematics, but there were, I mean, in the worst way possible, there were, in the, so, okay, tell me a number, I'll tell you if it's even or odd. Let's see, so let's put in 5 and hope that I did this right. 5 is odd. Oh, and so this is not really related to, and okay, spin degree 1, 2, 3, tell me a number, let's say 14. Okay, 14 is even, and let's ask what it thinks about 0. 0 is even. And now let me do one last thing before we end class. So the one last thing I want to do before we end class is this. I want to talk about what happens when you put in, so remember this, we're always counting integers, right, before we do anything. I want to say, hello there. Okay, so what just happened here? What happened here is that you typed, or I typed, a string into something that was getting converted into an integer, and it exploded, right? This is what's called an exception, and Python throws them whenever you do something really bad. Well, moderately bad. And so basically the point here is that it doesn't like it when it tried to do the conversion, so it killed your program. Now, the question is, do you have to do anything about this? The answer is, you at this point should not assume that we give you good numbers. So for instance, if I say enter a positive number, I might type in a negative number just to test what your code does, right? If I say enter pos number, I may enter a negative number. But I will not enter a float, a string, anything like that. So basically the reason is because you don't have ability to catch these yet. So don't worry about it. So you can assume that whenever you ask a question, we will give you the correct type. Okay, that's what you can assume in this class. So whenever you cannot assume that we're going to give you good numbers. You could say enter a positive number, and I enter -3. Or if it's floats, you could say enter a number with 3 decimal places. I enter the number 4, right? I could give you bad input, but it's always going to be of the correct type. And the reason is because otherwise you're going to end up with these exceptions and you won't be able to do anything. So basically, that's the point. So you may not have good numbers, but you will always have good types. Unless, of course, later in the semester I might cover exceptions, at which point, like towards the end of the class, you'll be able to catch these things. Okay, so I think that's all for today. I'll upload this to the GitHub. First thing I'm going to do is just scroll, you make scroll face and delete, and then there we go. Let's commit. You could, but the problem is that you would want to do that. So for instance, you would say like, you know, entered number equals int input, enter a positive number. And so that, what you would do is you would say if entered number is bigger than 0, print good, else print bad. But, and so this, you know, when we get to while loops, you can use a while loop to go through this over and over and over and over and over until the user gives up and enters a positive number. It still will crash on a string. Is the GitHub on Discord? I think maybe. Is it? Is it in the announcements? I guess I didn't post it. I can post it. That's not hard. Let me just let me recommit. And then I will push. And then I will post, and then we will sign off. Okay, I'm sorry about the issues today. I'm going to call my ISP and tell them that this is getting nuts because they can't do this anymore. Okay. All right, I'll sign off now. Have a good day, everyone.